Welcome to clickmyproject.com. Image compression with short-term visual encryption using the Burrow-Wheeler transform and keyed transpose. In this work, we are presenting image results of using BWCA Burrow-Wheeler compression algorithm on images with the proposed conditional transposition methodology keyed transpose for a short-term visual protection and the results for the subjective metric perceptual assessment of the quality and the BWT effects on the images. The BWT Burrow-Wheeler transform is used for the compression. The BWT is applied on a one-dimensional set of data. The output is generated according to the following scheme. All the different rotations of the original data sequence are formed and arranged in a sequence square matrix is in ascending order, whereby the elements of the first column are the most significant. Store the number of the row which contains the original sequence as the index 1 in order to allow the inverse transform to be successfully applied to the transformed sequence. Take the last column as the output of the transform. This is the overflow of our project. It consists of load image. In the load image block, we will load the input test image. After that, the input image pre-processed using any one of the filtering technique. In pre-processing method, the median filter is used to remove the noise from the input image. It is often desirable to be able to perform some kind of noise reduction on an image or signal. The median filter is a non-linear digital filtering technique often used to remove noise. Such noise reduction is a typical pre-processing step to improve the results of later processing. Median filtering is a very widely used in digital image processing. The next one is the the input image color image means then the image is converted into grayscale image. After that, the BWT is applied. BWT is nothing but the Burrow-Wheeler transform. The image is compressed using the Burrow-Wheeler transform. The BWT is applied on a one-dimensional set of data. The output is generated according to the following scheme. All different rotations of the original data sequence are formed and arranged in a square matrix in ascending order, whereby the elements of the first column are the most significant. Store the number of row which contains the original sequence as the index 1 in order to allow the inverse transform to be successfully applied to the transformed sequence. Take the last column as the output of the transform. After that, before run length encoding applied to the input image, GST is applied. After that, run length encoding is applied. In run length encoding performs lossless data compression and is well suited to palette based bitmapped images such as computer icons. It does not work well on continuous tone images such as photographs, although JPEG uses it quite effectively on the coefficient that remain after transforming and quantizing image blocks. The more commonly used RLE encoding method is RLE0. The run length encoding has many variants. However, we have chosen the RLE0 as entropy coding stage. The next is move to front transform. The move to front algorithm was the part of the data compression algorithm defined in the original paper by Burrows and Wheeler. An MTF encoder keeps all possible data values in a list. It processes the input one value at a time by simply outputting that value position in the list. It then moves this value to the top of the list, so if the next value to be encoded is identical, this time is outputs as A0. On repetitive data such as that produced by DBT and MTF encoder produces an output heavily weighted towards low integers and are likely to include runs of those integers. These runs can be run length encoded. After the encoding, we can calculate the performance analysis of our overall system. In performance analysis, it's done by calculating the PSNR value. Peak signal to noise ratio is an approximation to human perception of reconstruction quality. It is calculated based on the mean square error value. PSNR is high for enhanced image. Open the source code folder, select BWT main.m file, right click on it and select run file. This is our guide designed window. Select the input image by pressing this push button. Select the input image from the dataset, any one of the image. We have inserted a color image and a background image. Select which image you have to choose. Next, apply BWT encryption. The figure shows the The figure 1 shows the histogram value of the input image. Next is I upload a BWT encryption. This is the sorted image, and after that I calculate MTF. MTF process completed. And then I apply a run length code. This UI table displays the run length code of our image. After that I can apply the keyed transpose for the input image. This is keyed transpose of the input image. After that I can apply the speed compression for that input image. This is the compressed image. Displayed here. After that select next to from the next window apply script decoding. The UI table displays the script decoding. After that the keyed transform is applied. This is the keyed transform, and after that calculate run length decode. This is the run length decode, and apply inverse BWT. This is the reconstructed image. In the analysis we can display the performance evaluation values here. CR, BPP, CR and BP of the input image and our output image. From this our existing compared to existing algorithm, our proposed algorithm performs better than the existing one. Thank you.